Hi and welcome to the Nourished Hoof. My name is Paul Conroy. Thank you for watching the video. This video is going to be on the hoof capsule itself, okay? And we're going to talk and we're going to have a look today at, the internal structures, or the names of some of these internal structures inside the hoof capsule. So we all recognise a hoof capsule. This is a real hoof of a cadaver limb. Obviously we all recognise it, and if we turn the foot over we can see that we have perfect half of a horse's foot. So if we look inside our sagittal section, we can see that there is a lot of anatomy going on inside the hoof. So the first structure that we're going to discuss is this bone here. This one is the distal phalanx, or P3, or coffin bone, depending on which terminology you use, but its correct anatomical term is the distal phalanx, okay? And it's the bone completely encased inside the hoof capsule. We have the bottom end of the middle phalanx, or P2 as it's sometimes known. Half of it is missing. The half that's outside of the hoof is missing because it's been taken off. And then the final bone that we can see in, essentially, this is the sagittal plane, but essentially for you in side view is this bone here, and this bone here is the navicular bone. Okay, occupying a large area in the back of the hoof. Hopefully you can see this white fibro fatty pad. This fatty pad is known as the digital cushion, and it's responsible for absorbing a lot of the concussion and landing forces associated with a 500 kilo mammal moving at speed across the ground. It generates a lot of impact vibration, and this cushion, digital cushion, absorbs a lot of that. It extends all the way to the front of essentially the distal phalanx, just past the navicular bone. It starts to thin, okay, but it occupies the whole sort of back half of the foot, and it's responsible for, it's the main structure that is responsible for the hoof moving under load. The heels will move out and move in when load is applied to them. The squashing of this digital cushion is what is responsible. Directly below it, we've got, if I turn it over, we've got the frog, and the frog extends here in this area, okay? This is the frog. Obviously we've got the horny frog, or the insensitive frog, and then the frog, the more sensitive frog underneath, and the frog chorea that produces the frog, as well as structures like the frog stay. Any farriers vets watching this will know all about the frog stay and the role it plays in weight bearing. And then we've got the top bit here, the digital cushion. Okay, if we take a look now at this structure, again, I'll put my pen on it. This structure that runs down, it runs over the navicular bone. This is our navicular bone here. It runs over the navicular bone and it inserts onto a thing called the semilunar line, which is just here, fans out and inserts all the way around. That is the deep digital flexor tendon, and as the name suggests, it is what is responsible for flexing the digit. Essentially, it pulls the toe into the ground on when the foot's on the ground, okay, and it's responsible for lifting the heels off as the horse unrolls and goes off into the next stride. So really, really important structure and important tendon. The other tendon at the back is the tendon called the superficial digital flexor tendon, which inserts at essentially at the top of this bone here, what we know as P2, and the bottom of P1. So they're missing off this particular model. Okay, and then at the very, very bottom of P3, just here, we've got a place called the distal fringe. And at the distal fringe, there are what we call small terminal papillae, which point downwards, and they produce the white line. This is the white line just here. We all know the white line on our horse's feet. This attachment between the bone and the hoof wall, this is our laminae attachment. And obviously the laminae attachment is quite complicated, so we'll keep it nice and simple. Basically, there are two types of laminae on each side. On the hoof side, we have two types of insensitive laminae, known as the primary and the secondary. And on the foot side, or the skeleton side, we have two types of laminae called the sensitive primary and primary and secondary laminae. And those two intertail with each other, or dovetail with each other, and essentially hold the skeleton onto the hoof wall itself. And then we have the main bulk of the actual hoof wall. You can see how thick the hoof wall is. Obviously, this is a particularly nice foot. The worst feet there are, then the less this thickness. This thickness can vary greatly. This one's a good example of a good thickness of hoof wall. And then at the very top here, okay, we have, I'll bring it a little bit closer, we have an area called, let me just find it, here it is. is the coronary corium. It's just here, this mass. It's basically a half round fibrocartilaginous roll off which the papillae, basically there are little hair-like projections that project off this half round fibrocartilaginous roll, and that is what grows the hoof capsule, and it sits in a thing called a coronary groove. This is the coronary groove just here. This is our coronary corium. This is where the hoof wall is grown inside this area. Basically the cells, they produce large amounts of keratin, they die, they harden, and they stay in the hoof wall, and it's what produces the hoof wall. Now there are three types of horn, essentially: horn tubules, intertubular horn, and intratubular horn, and they all perform different jobs within the hoof capsule, but they're all produced up here at the coronary corium. On the outside of the foot, we have a structure that's been removed called the periopal, and it's this scaly stuff that you see at the top of the hoof just here. Now in some horses it will extend, and it should really extend as far down as possible. It's known as the stratum externum, and it's basically a moisture conveyor, and it stops infection getting into the coronary band, but it can take in moisture from the outside, feed up to the coronary band, and keep everything nice and supple in this area. Now it receives the majority of its sort of nutrients and hydration from the blood supply, which is why the blood supply in this region is really important. And again, don't really have time in this video to go into how the hoof is supplied with blood, particularly this region, the coronary band region, but it does have a good blood supply, which feeds into one of our products, which is the caffeine daily emollient, which is specifically designed to stimulate this area to maximize blood flow for hoof growth, and obviously for nourishment and keeping the horn tubules nice and supple. So the coronary band region is an important region when we're talking about the anatomy of the hoof capsule, and the magic happens up here. So again, we've got our coronary corium sat in our coronary groove, and at the top of the coronary corium, right at the top of the coronary band, under the hairline of the hair, we have a thing called the perioplic corium, which is a much smaller corium that sits in the perioplic groove, and that produces this stratum externum, or the periopal, on the outside. The other stratums are the stratum medium. The stratum medium is the main bulk of the hoof wall, and then we have the stratum internum. I'll bring it a little bit closer. You can see that the hoof wall has what we call an unpigmented zone. Now this is a white hoof anyway, but you can see even on white hooves, there's an area where it goes bleached white. There isn't that bit of the hoof carries no pigmentation, and every hoof, black hoofs have it. If you drill down into a black hoof, you would eventually hit the unpigmented zone, and the unpigmented zone and the insensitive laminae form the stratum internum of the hoof. Now all these structures need to be healthy and nourished, and good blood supply and everything like that in order for them to function properly. Remember, you have a 500 kilo mammal above it that's moving at speed. The hoof undergoes a tremendous amount of stress and will fracture and break if it's not cared for. All right, I hope you found that useful, and I will see you on the next one.